Earth doesn't need aliens to go extinct. The universe already has several ways planned. Right now, while you're watching this video, there's a star somewhere in our galaxy that could detonate and cook our planet like a microwave burrito. There are asteroids we didn't even know existed until they screamed past us. And there's a possibility, small but real, that the entire universe could just stop working. I'm talking about gamma-ray bursts, rogue planets, vacuum decay, and cosmic threats so absurd they sound like sci-fi. But they're not. They're real, and some of them we wouldn't even see coming. So buckle up, because we're about to tour the universe's kill list. Let's start with the universe's sniper rifle, gamma-ray bursts. Picture this. A massive star, way bigger than our sun, runs out of fuel and collapses in on itself. In seconds, it forms a black hole. But as it does, it releases more energy in 10 seconds than our sun will produce in its entire 10 billion-year lifetime. That energy? It fires out in two narrow beams of gamma radiation, traveling at the speed of light, cutting through space like cosmic lightsabers. If one of those beams pointed at Earth, game over. The gamma rays would shred our ozone layer in minutes. Without that shield, ultraviolet radiation from the sun would sterilize the surface. Plankton dies. The food chain collapses. Mass extinction will happen so fast. The terrifying part? We wouldn't know until it hit us. Gamma rays travel at light speed. There's no warning, no time to prepare, just lights out. Now here's the kicker. Scientists think gamma ray bursts might have already caused mass extinctions on Earth. The Ordovician extinction, about 450 million years ago, wiped out 85% of marine life. Some researchers believe a gamma-ray burst was the trigger. Good news, gamma-ray bursts are rare, and they need to be pointed directly at us. Bad news, there are candidates. WR-104, a star about 8,000 light-years away, is on astronomers' watch list. It's massive, unstable, and might be aimed our way. If you're loving this, like the video, subscribe for more space mysteries, and share it with a fellow space nerd. And drop a comment. Which space threat freaks you out the most? Okay, new nightmare. Imagine a planet, frozen, dark, no sun, just drifting through the galaxy like a cosmic wrecking ball. That's a rogue planet. These things got ejected from their solar systems, probably during some chaotic planetary pinball game billions of years ago. Now they just wander. No orbit, no light, silent, invisible, and there could be billions of them in our galaxy alone. So what happens if one crashes our solar system? Best case? It passes through the outer edges, nudges some comets, and leaves. Annoying, but survivable. Worst case? It barrels into the inner solar system, destabilizes planetary orbits, and sends Earth careening into a new trajectory, either freezing us into an ice ball or flinging us into the sun. Or it just hits us. A planet-sized cannonball at tens of thousands of miles per hour. The impact would vaporize the crust, boil the oceans, and turn Earth into a second asteroid belt. Here's the wild part. We've barely started looking for these things. They don't emit light. They're freezing cold. The only way we detect them is through gravitational microlensing. Basically, watching them bend the light of stars behind them. It's like finding a shadow in the dark. NASA and other space agencies are trying to map them. But right now, a rogue planet could be headed our way, and we'd have maybe a few years warning. Maybe. Alright, let's bring it closer to home. Our sun. Friendly, warm, life-giving, and occasionally a total maniac. In 1859, a solar superstorm called the Carrington event slammed into Earth. It was the most powerful geomagnetic storm ever recorded. Telegraph systems exploded. Operators got shocked. The auroras were so bright, people in the Caribbean could read newspapers at midnight. Sounds cool, right? But remember, this was 1859. We didn't have power grids, satellites, GPS, the internet. If the Carrington event happened today, it would be catastrophic. The storm would fry transformers, collapse power grids across entire continents, and knock out satellites. No GPS, no internet, no communication. Hospitals on backup generators, water treatment plants offline, supply chains frozen. Experts estimate it could take months, even years, to recover. And the economic damage? trillions of dollars. Here's the scary part. We've had close calls. In 2012, a Carrington-level solar storm missed Earth by just 9 days. If it had hit, we'd still be rebuilding. NASA and NOAA monitor the sun 24/7 now, and we've got early warning systems. But even with notice, there's not much we can do except shut down the grid and hope our infrastructure holds. The sun's been quiet lately, but it won't stay that way forever. February 15th, 2013, Chelyabinsk, Russia. People are driving to work. Suddenly, boom! A meteor explodes in the sky with the force of 30 Hiroshima bombs. Windows shatter across the city. Over 1,500 people injured. And here's the thing. Nobody saw it coming. This asteroid was only 20 meters wide, about the size of a house, but it released 500 kilotons of energy. If it had hit a major city directly, thousands dead. And it's not the only one. In 2019, asteroid 2019 OK, a 100-meter rock, passed within 73,000 kilometers of Earth. That's closer than some satellites. Astronomers didn't spot it until it was almost on top of us. Why? Because it came from the direction of the sun. We were basically blind. We know asteroids can end civilizations. The dinosaurs learned that the hard way 66 million years ago. A 10-kilometer rock hit the Yucatan Peninsula, triggered mega tsunamis, global wildfires, and a nuclear winter that lasted years. Could it happen again? Absolutely. NASA's tracking thousands of near-Earth objects now. We've even got a planetary defense mission, DART, that successfully smashed into an asteroid in 2022 to test deflection tech. But here's the truth. We've only mapped about 40% of potentially hazardous asteroids. The rest? Still out there, waiting. Okay, time for the existential horror. Everything I've talked about so far, gamma ray bursts, asteroids, rogue planets, those are all physical threats. But there's one danger that's not physical. It's structural. What if the universe itself is unstable? Welcome to vacuum decay. So, in quantum physics, there's this thing called the Higgs field. It's what gives particles mass. It's everywhere all the time, like an invisible energy ocean. And right now, it's in what's called a false vacuum. Basically, it seems stable, but it might not actually be. Think of it like a ball sitting in a shallow dip on a hill. It's stable until something nudges it. Then it rolls down to a lower energy state, the true vacuum. If that happens anywhere in the universe, if the Higgs field suddenly drops to its true vacuum state, it creates a bubble of new physics. And that bubble expands at the speed of light, rewriting the laws of reality as it goes. Inside the bubble, atoms don't work the same way. Chemistry changes. Stars can't form. Life can't exist. And because it moves at light speed, we'd never see it coming. One moment you're watching YouTube, the next moment you stop existing. The concept of you stops existing. Now, before you panic, this is all theoretical. The Higgs field has been stable for 13.8 billion years. Most physicists think we're probably fine, but here's the thing. We don't know. We can't know. Vacuum decay is the ultimate cosmic wildcard. It's the universe's self-destruct button, and we have no idea if someone's hand is hovering over it. So yeah, the universe is terrifying. But here's the flip side. We're still here. Against all odds, against gamma ray bursts and asteroid impacts and solar storms and rogue planets and the possible collapse of reality itself, we've survived. Humanity isn't just sitting around waiting to get wiped out. We're building asteroid deflection systems. We're monitoring the sun. We're scanning the skies. We're asking the big questions. And maybe that's the point. The universe might be dangerous, but it's also amazing. And we get to be here right now trying to figure it out. If you want more cosmic nightmare fuel, and let's be honest, you do, hit subscribe. Drop a comment with the space threat that freaks you out most, and I'll see you in the next video. Stay curious, stay alive.